Okay, this is MECH1395 hydraulic activity number 5. We're starting off with a fairly familiar circuit, single-ended cylinder, double acting, controlled by our directional control valve, which is solenoid operated, 3-position, 4-way, tandem center, spring-centered. And we have flow meter F1 measuring the flow going into the valve, into the cylinder, and F2 measures the flow going out of the relief valve and back to tank. So we've seen this circuit before, simple reciprocating cylinder, and if we simulate it, we can make the cylinder extend by shifting the valve. Full flow goes to the cylinder, no flow goes through the relief valve until the cylinder is extended and deadheaded, at which point we can set our valve and retract it the same way. While it's retracting, again, 1 GPM going in, no flow going through the relief valve, and it retracts and extends at full speed. Whatever speed 1 GPM and those two retract and extend areas provide, that's the speed it goes at. If what you need is to control the speed of the cylinder, there's a way to do that, and it's called metering. We're using this valve, a metering valve. It's a one-way needle valve, with a check valve beside it. And there's different ways we can use this. There's different configurations. And it's not exactly obvious what's going on, but in fact, the reason why this valve can be used to control the cylinder speed is that as you close this needle valve down, you create resistance to flow, which increases the system pressure down here. Let's watch this. I'm going to start off with this valve fully open. Put the directional valve in its neutral position here. And I'll start with this valve wide open. So we have pump flow going at 1 GPM through the flow meter, through the valve, neutral, back to tank. No flow through the relief valve, and this is wide open. Again, we can retract the cylinder at full speed, and when you do that, pump flow goes into the retract chamber and flow comes out to the extend port, and it comes to this valve, and it could go through this needle metering adjustable part, or it can just go freely through the check valve and back to tank. To extend the cylinder, flow has to go through the needle valve. It can't go through the check valve. Right now the needle valve's wide open, so we don't have any speed control, and we can still see that it was full 1 GPM going to extend the cylinder. What I'm going to do though is I'm going to close this valve a little bit. I'll make it about only half open, so it represents some restriction now. When I extend the cylinder now, watch what happens. Full flow, still 1 GPM going in there, slightly higher pressure. Maybe I need to close this a bit more. Let's try it again at this particular closure. Retract the cylinder. And while I'm extending the cylinder, look at F1 and P1. F1 is 1 GPM, full pump flow. Look at P1 though, it's 300 PSI. And it is because this valve is partly closed and is making resistance to flow, and it induces a pressure all the way back. However, that pressure isn't enough to open the relief valve. So all we've done is made the pump work harder to push the cylinder out at full speed. That's of no use at all. We haven't started reducing the speed yet. In fact, what you need to do is close this valve sufficiently. I'm going to try how about 14% closure? These are just sort of relative numbers. But I've closed it down even more. Watch what happens when I extend it now. The resistance to flow causes 550 PSI here, which partly opens this relief valve. So I have about half a GPM going to the cylinder and half going through the relief valve back to tank. So the cylinder extend speed is slower. I'm only getting about half the pump flow to extend the cylinder instead of full flow, so it goes at about half speed. And the reason it does that is this metering valve has made it difficult enough to pump the oil that this relief valve partly opens. It's a bit of a shame, but in this animation this little arrow that goes through the valve, it's either in the middle or off to the side. It doesn't have any intermediate kinds of positions. So this valve isn't fully open while it was extending. It is now, because the cylinder is deadheaded and all the flow, 1 GPM, is going through the valve. While we retract, flow goes out through the check valve, so there's no restriction. So what we have now is metered in on extension. During extension, the flow going into the cylinder is metered. It's got some resistance to it that sends some of the pump flow through the relief valve and slows the cylinder down. But the retraction has no speed control because the flow coming out just goes freely through this valve back to tank. So what this metering is called, this is called metering in on extension, or metering in during extension, or metering in for extension. It's metering to control the extend speed, and the way that it does it, it's a little surprising. It's not just a matter of closing this valve down, it's a matter of closing it down enough that the pressure back here goes up and up and up, and the speed won't start to reduce until you get this pressure high enough to partly start to open this relief valve. That's how metering works. It's not super obvious, but you get speed control by sort of a delicate balance between the performance of this metering needle valve and this pressure relief valve, taking away some of the flow to slow down the cylinder. There's other ways we can do this. We can look at this operation here and see if you can figure out what's going on here. This also provides speed control for extension, but the oil is metered out. Let me retract the cylinder. I'll set this to, I don't know, some setting. And when we retract the cylinder, pump flow goes freely in through the check valve to retract the cylinder at full speed. But when we extend it, oil flows into the extend port from the pump, but coming out, it has to go through this needle valve. So it keeps the pressure inside the cylinder that's transmitted all the way back here. Again, watch the extension and look at P1 and the flow on flow meter 1. Oh, it's pretty much at full speed. I need to close this valve some more. Let's try it again. Full speed retraction and possibly a metered extension. Oh yeah, see that? About a half a GPM. So it's extending slowly, but look at this high pressure here, 970, 540, 550. This is what happens. This is called metering out on extension. The valve is connected to the retract port, but it's there to control the extend speed. This valve creates resistance to flow in the oil coming out of the retract chamber, which causes pressure in the retract chamber, which must be overcome by pressure in the extend chamber, which is supplied ultimately back at the pump outlet. So this valve sort of getting in the way of the oil coming out of the retract port during extension, that's what makes this slow down. It causes pressure here and all the way back here and sends some of the flow through the relief valve. The only way to control the cylinder speed is to slow it down by taking away some of the pump flow. That's all there is to it. There's other ways of doing it, but this is sort of the basic way. This has an odd problem though. We have our system relief valve set for 600 psi full flow. So we've got 600 psi on P1 when all the flow is going through the relief valve. So you would think this relief valve would limit the system pressure to 600 psi everywhere, but it doesn't. Watch what happens to P3 during extension with metering out on extension. This pressure is almost 1,000 psi, 970 psi, because this pressure is the pressure, same as P1, it's the pressure that opens up this valve to take away some of the flow, but it causes a higher pressure on P3. It's an intensified pressure. It causes a higher pressure in the retract chamber than you might expect, higher than the relief valve setting. In fact, it's the area ratio higher. The worst case would be if we close this valve entirely during extension. So if I close this valve all the way down to 0, so oil just cannot get out. I try and extend the cylinder, and the cylinder is essentially deadheaded. Pump flow is trying to go through here. There isn't any. It's all going through the relief valve at the full 600 psi, and it goes in here into the extend port, and this 600 ps oil is pushing on the big area, the extend area of the cylinder, which is creating pressure on the other side, but higher pressure. Look at that, 600 psi here over 1000 psi here. This is a potential hazard that you can have when you're doing metering out on extension. It happens only during metering out on extension. It's called pressure intensification, and you got to be a little bit careful. This pressure might be higher than anybody really expected if they weren't paying close attention to what's going on in this circuit. This intensified pressure, well, it could actually cause damage. You might blow off some lines. If this system was running at 3000 psi, you might end up with 3000 psi here and maybe 5,000 or 6,000 psi on the other side, possibly enough to do damage to, well, the cylinder itself and this line or this valve. That's pressure intensification. It only happens when you're metering out on extension. There's a few other ways of doing metering. If we wanted to control the retract speed, for instance, this valve here, you can see the check valve now is, it looks similar. Let's go back to this one. This is metering out on extension. You see the direction that the check valve is facing? I'll de-energize the cylinder. This is a new circuit now. This is different. The check valve is facing the other way. That means flow, pump flow has to go through the needle valve on the way in, and it's free to come out when this is extending. This valve gives us metering in during retraction. If I close this valve down and retract the cylinder, it creates back pressure that sends some flow through the relief valve, so there's less flow to the retract port and it retracts slowly. The flow out of the extend port back to tank is free, unimpeded. When we extend the cylinder, pump flow comes into the extend port and the flow out the retract port goes freely through the check valve back to tank. So it only has to go through the needle valve on the way in. It's free to flow on the way out. So on the way in, which is retraction, that's when we have speed control. One more operation or version of this is shown here. This is metering out on retraction. This valve, again, the check valve is oriented like this. It means that this flow coming out of the cylinder has to go through the needle valve. Flow going into the cylinder is free. This arrangement is called metering out on retraction, and it controls the retract speed. Again, let's watch this. I'll close this down to some value. And when the cylinder retracts, pump flow goes into the retract chamber. This is closed down. Oh, that's pretty slow. I'm only getting quite slow retraction. Only a little bit of flow is going to the cylinder, and the rest, almost 1 GPM, is going through this relief valve. So that's pretty slow. I can increase this by opening that valve a little bit. And now we have a faster retraction. Well, not much faster. So notice the flow coming out has to go through the needle valve. To extend it, flow goes in freely through the check valve and comes out freely to tank. So there's no speed control on extension, just retraction. And it's because the oil being pushed out of the cylinder has a back pressure. See this pressure here in P2 inside the cylinder? It's caused by the resistance to flow through this needle valve, which creates a higher pressure here, which is the same as the pressure back at the pump that pushes some flow through the relief valve. So we have metering in on extension and metering out on extension to control extend speed. And we have metering in on retraction and metering out on retraction to control the retract speed. The dangerous one is the one with metering out on extension. This is the one that can cause a pressure intensification problem in here and result in potentially dangerously high pressures, certainly pressures higher than the relief valve is set for, which might make you wonder why ever bother with this at all. If you can control the extend speed with metering in on extension like this, and there is no problem with pressure intensification, right? This pressure is 0. The pressure inside the cylinder is low. So why ever use the one with a potential problem? Well, it's because sometimes loads can be so-called overrunning loads. If there were a load tending to pull this piston rod out, something in the external world that tends to pull this out hard, metering in doesn't really work. You just push the oil out of the retract port back to tank and you can draw a vacuum in here. But metering out on retraction, imagine if during cylinder extension you're also pulling really hard to the left on the piston rod. Let me increase the speed. Well, pulling hard on the piston rod would tend to push this oil out through the valve that's controlling it. So metering out is good for controlling so-called overrunning loads. Overrunning loads are external loads that are in the same direction as the cylinder's motion. If the cylinder is extending and the load on it is pulling it to extend, that's called an overrunning load, and you have to get in the way of the oil exiting the cylinder in order to control that. There'll be more on this later. I hope this helps.